Good morning, everyone. My name is Saeed Nobari with TAPI. I'd like to welcome you to today's webinar, Increase Process Uptime and Efficiency with Power Ultrasound Technology, sponsored by Altum Technologies. Today's presenters are Beta Arpanen and Esteban Soto. Beta Arpanen is an account executive at Altum Technologies. She's a Master of Science in International Business and manages several customer projects across the pulp and paper industry in Europe, America, and Africa. Esteban Soto is CEO Americas for Altum Technologies. He moved from Finland to USA to expand Altum's operations in the Americas in 2018. Besides taking care of marketing, operations, and sales in the American continent, Esteban has firsthand experience on project execution and installation of Altum's power ultrasound systems in several industries. This presentation and its discussions will be held in compliance with TAPI's antitrust policy. TAPI's aim is to promote research and education and to arrange for the collection, dissemination, and interchange of technical concepts and information in fields of interest to its members. TAPI is not intended to, and may not, play any role in the competitive decision of its members or their employers, or in any way restrict competition among companies. If you have questions throughout the webinar, please type them into the Q&A feature at the bottom of your screen. We will address any questions at the end of the presentation. Today's meeting will be recorded, and the recording will be available on TAPI's website in the next couple of weeks. A survey link to the recording and slides will be sent to all attendees. And without further ado, I'd like to turn it over to our presenters today, Beta Arpanen and Esteban Soto.
Thank you, Saeed. Thank you, TAPI, for having us today here. Thank you, everyone, for joining us. It's a pleasure to be able to present more about what Altum Technologies does and how we're helping the pulp and paper industry to increase process uptime and efficiency. Today, we'll be going through different topics. First, introducing a little bit more about Altum, how it all started, then through the problem, which is fouling in industrial equipment, how then we are solving this, and what mechanisms we're using by controlling power ultrasound to clean industrial equipment from fouling. Then my colleague Beta will go through different case studies and ongoing cases that we have in the industry, and we'll be wrapping up with a summary at the end. Altum is from Helsinki, Finland. We are headquarters in there, and actually my colleague Beta is based in there. We started since 2016 out of the need of the industry, not just pulp and paper, but in general, to be able to get rid of fouling and scaling. And fouling itself, it's a big global issue, and that's what we started in Helsinki. Then we have been expanding globally, and we opened an office here in the US in order to support North American clients, and that's why I am based in here. The problem is fouling. It's a global industrial one. It has been since the Industrial Revolution, always there, giving headaches to producers. And it all started with our founders. They were importing low power ultrasound devices to Europe. And one of their clients is actually from the pulp and paper industry, asked them, could you take care of bigger equipment like evaporators or pipelines or heat exchangers? Can you clean those? And then they tried with those initial devices, but the power wasn't enough. So they started on a quest to find a technology that could then help their clients, and they couldn't find one. That's when they turned into experts from the University of Helsinki, Professor Edward Häggström. And with him and his team, then they were able to create the technology that we have today. From then on, then it was possible to treat, clean, prevent fouling from industrial equipment and big industrial equipment. So the issue, and probably this is very well known to everyone, is that fouling is decreasing the energy efficiency of production. It's stopping the production process because you need to clean, you need to either change of equipment or open it up to get it up to speed again. And not only causes impact in your production, but also environmentally, as many times harsh chemicals are used, or also a lot of water is used for these cleanings. And once the production gets inefficient, then also more energy is needed, and more CO2 is emitted to the atmosphere. So on top of this, then we have a lot of issues like in the costs of things. Production loss due to fouling and heat exchangers alone cost approximately 200 billion of the annual GDP in the top 10 economies. And this is a massive issue as well. It's not just affecting one company, but entire economies. So the next slide I'm going to present is a video showcasing the whole idea of our technology. So it will give you a better visibility of how it can be applied, where it can be applied, and you will see in real time what it can do to fouling and how it detaches from, in this case, it would be a pipe. So we have here a dirty pipe, for example. Our system will wrap around externally, and with the ultrasonic transducers, we'll be then using that ultrasound, which will penetrate the equipment. In this case, is a pipeline, and it will be then cleaning everything what is inside. We have here lime scale, which was like hard as rock, and this was the results after 1 minute. We divide our system in 3 different modules. The first one, which is the most important one, it's the software. That is basically the brain of the solution. We can control several parameters, transducer by transducer, so that we get to the specific efficiency needed to treat and to allow us to get rid of those fouling issues that you may have. We can also control it remotely through our software, so that it doesn't matter if we are not on site. We can make sure that everything is going according to plan. Then we have the central unit, which is what translates electrical power into ultrasonic power. It's all the electronics needed to be able to fulfill this, and it can take up to 8 channels. We call channels what is transducer plus the necessary electronics needed. It is robust so that it can deal with harsh conditions on the field. Then we have the transducers, which is what then you will be applying externally via different types of mechanical attachments depending on the case. The most usual one is the one that you saw in the video, which is a clamp-on device, very easy to attach and to apply. No need to do any modifications to the equipment. And that is one of the key aspects of our design, and something that also our clients were asking from the beginning, because they didn't want to do any modifications to the equipment to compromise also the equipment itself. Like they didn't want to weld, for example, or just modify it. So that's why we designed it in this way, so that it's very easy to install and no need to do any modifications to your equipment. Use and applicability, when it comes to the software, we can pinpoint exactly where we want the ultrasound effect. So we can guide it to where it's needed or how it's needed. Later on, you'll see more ways in how we apply the ultrasound. It's not just to get rid of fouling, but also to create small crystals or to treat liquids there are different ways that we can then use our parameters to control the ultrasound, high power ultrasound as we really want. The software itself is based on advanced physical model simulations, which our team has been able to produce. It's a proprietary software. Then we have the following types. This is what then will give us an idea of how much power is needed to get rid of a specific type of fouling. So for example, if we treat biofilms of biofouling, polymers, for example, those are more elastic. So the molecules will attach to them to itself with ease, and also it will be very difficult to break. And that's why then we need higher ultrasonic power to treat those type of foulings. But then we have, on the other hand, mineral scaling or some types of chemical fouling that they are very easy to break. They are brittle. So in those type of cases, then we don't need to go as high in ultrasonic power. So far, we haven't seen any type of fouling that we can't treat. It's just about finding the right conditions and the right system parameters to get to the results needed. Applicability on different types of materials like steel and alloys, other alloys, that's the best case scenario. Then we have fiberglass, which we can also work with. And when it comes to plastics, that's when we don't apply directly to, for example, plastic pipes, for the same reason that plastic is not the best conductor. So we have several other ways on how then we can deal with this type of materials, but we don't apply directly on plastic. Then when it comes to the content of the equipment, we don't apply to gas or dry content for the reason that we need liquid so that the ultrasound can then travel with ease and get the effects needed so that the power is not attenuated. So it works in liquid carrying equipment, from water, oil, chemicals, food products, polymers, you name it. So as long as there is liquid, the ultrasound will then have a desired effect. And then based on that liquid type, then we know what kind of parameters we should be using. Related to the cleaning mechanisms, we can go really, really deep into this, and please let us know, and feel free to contact us at any point or ask more questions if you want to know more, and then we can then get back to you on those so that we can even have people from our technical team join any future meeting and then go very deep into this if you're interested in knowing more. Basically we have different mechanisms in how we can then control ultrasound to get to the result that we want. The most effective way to remove fouling inside of an equipment is just to place the transducer directly on top of where the fouling is, so that then we can then produce the sound waves really close to that. Then we can play around with the locations of the transducers so that we can put them along the vessel, and in that way the ultrasonic waves will interact with each other, and that will spark even higher efficiency of cleaning or prevention. We also can go very high in power in order to produce microscopic bubbles in the process liquid. In that way then we are going to play with small quantities of pressure, high and low. And by doing this, then we'll be interacting with the fouling, and that's how then it will be detaching from the surface of the internal surface of the equipment. We have other ways to do this also. For example, in prevention, we create, so to say, a protective layer inside the equipment so that fouling is not attaching to the wall of the equipment. Another way is to treat liquids, which is what Beta will show later on in our cases, in where then by treating the liquid itself, we are also inhibiting this position or disposition of the crystals that will produce later fouling in equipment like heat exchangers or evaporators. All in all, the best way also to keep your production up and running efficiently is not just to wait until the equipment is dirty, but also to prevent from happening altogether. So we are very experienced in both situations, and in many cases, prevention is the best way to go, so that you don't have to worry anymore about your equipment fouling. Now I'll give the space to my colleague Beta so that she can go through different case studies and ongoing cases that we have been working with.
Thank you, Esteban, and thank you all for joining us today. So we have been working with several projects, and I will today present 2 evaporator case studies and then go through some of the ongoing cases that we have currently in pulp and paper industry. Yes. So as Esteban mentioned earlier, our company started when our founders found out that there are not enough high power ultrasonic devices on the market. They collaborate earlier with Stora Enso, and Stora Enso is actually one of the company behind our idea. We have been collaborating with them over 4 years now, and with Stora Enso Heinola mill here in Finland. The mill had struggled for a long time with calcium-based fouling issues in their evaporation process, and tried to find a solution to prevent fouling inside their evaporators when the process is ongoing. They have 7 tubular black liquor evaporators. The evaporators are in series, and the evaporation process starts from evaporator number 6 towards the last evaporator 1A. And when the black liquor flows towards the last evaporator, the temperature, the dry matter, and the black liquor's viscosity increases, causing fouling issues, especially in the 2 hottest evaporators, 1A and 1B. The tubes inside the evaporators clogged severely, and thus the customer needed to stop, open, and mechanically clean these 2 evaporators even twice a month. So as you can see here in the picture, our solution was attached on the inlet pipes of these 2 hottest evaporators. And instead of using dozens of ultrasonic transducers, we were aiming to treat the black liquor which is going inside these evaporators to create the so-called sonocrystallization effect, to make the calcium crystals in the black liquor smaller and also less prone to attach inside the tubes of the evaporators. And together with the customer, we did different tests with different parameters. And finally, we found the optimal parameters and optimal setup for keeping clean these evaporators. After that, they have been able to keep the evaporators clean and decrease the need to clean these evaporators from twice a month to once per year. Also, we have been able to keep the process stable without unplanned production stoppages. Then we can move to the other case. So Sappi heard about us and what we are doing with Stora Enso, and also they wanted to try our solution since they also had struggled fouling issues in their evaporation process. So we started the collaboration with one of Sappi's South African mills in 2019. And as you can see in the diagram, the mill has 3 effect evaporators and a heat exchanger that are all connected in series. The evaporators aim to increase the dry material content from 15% to over 55% in red liquor. So the red liquor is coming in the evaporator 4, and then in the heat exchanger, and last in the evaporators 1 and 2. The bottleneck of the process was also the hottest evaporator, which is in this case the evaporator number 1. It was cleaned manually several times per year, even monthly. And when this evaporator needed to open and clean, the customer needed to stop the whole evaporation process because the whole process is in series. So like in the previous case, our solution was attached externally to the inlet pipes of evaporator 1 to prevent fouling from accumulating inside the evaporator's tubes. And only after a couple of months of operation, the customer was able to see benefits and also good results. We were able to increase the time between mechanical washes by more than 60%, but also improve the energy efficiency of this evaporator by 50% and the operational time by 25%. The positive results were also seen in evaporator 2, which inlet pipe we were not attached, but the prevention effect also carried from evaporator 1 to the next evaporator 2. The energy efficiency of evaporator 2 was increased by more than 40%. To give you a bigger picture where our solution is used and where it can be used and how versatile our solution is, I'm going to shortly present some of our ongoing customer cases in pulp and paper mills. At the moment, we also have 2 other evaporator cases in 2 leading pulp and paper companies in Asia. There we are also keeping clean the most fouled evaporators. However, these cases differ from the cases that I just presented, so that they have lamella evaporators instead of type tube evaporators, and the fouling type is mainly per gate. These are ongoing projects, but the results seem positive already. We are also preventing fouling in upper screen of the impregnation vessel, where mainly calcium-based fouling is clogging the screens and causing issues to the production process. Besides, we have a case in Europe where the customer's main fouling issues are in their critical production pipeline. They were not able to get rid of biological fouling and hemicellulose entirely with high pressure cleanings, and thus they wanted to try if our solution could clean the pipe. So first we did the cleaning trial, which was actually very successful, and we were able to clean the pipe section by section. And now we are preventing the growth of hemicellulose and biological fouling in that pipeline. As we know, there are lots of different fouling issues in pulp and paper mills that causing unplanned production shutdowns and reducing process efficiency. Also, the mills are going more and more towards closed loops. New fouling issues and regulations are coming, and our solution can be used in different parts, not only in evaporators, but also in pipelines, valves, filters, and so on. The one thing is that fouling prevention and cleaning of vessel is not the only objective where our solution can be used. You can also use our solution to improve your process. For example, we have a customer here in Finland where we are improving the separation of lignin, water and tall oil from each other in a customer's tall oil reactor. We have already seen that we have been improving the separation 2 to 5 percentage points, which help customer to gain more tall oil from their process. Our solution can also be used in wastewater treatment plants, where we can, for example, increase the dry material content of biosludge. So, as a summarize, and based on our experience with our current customers, here you can see some of the benefits in numbers that you can gain when using our system. We always collaborate with our clients and analyze the historical data that we get from our customers and comparing that data with the data after our solution has been installed. And as you can see, our customers have seen different benefits in their processes, especially in their evaporation process, which is often also one of the main bottlenecks in pulp mills. With our solution, you are not only able to reduce or get rid of mechanical and chemical cleanings and the unplanned production stoppages, but also improve the energy efficiency, capacity, and the operational time of vessel in almost any part of the process.
Thank you, Beta. As a reminder and summary, Altum is the only company to use software-guided power ultrasound to remove fouling from industrial equipment without the need to stop the production process and without the need to use toxic chemicals to do this. So by using our system, then your mill will be able to, first of all, remove and prevent fouling. That's our main goal. Regardless of the equipment and type of fouling, we are also always looking to different ways that we can then support you so that you can forget about those issues altogether. We can then, with your help, we'll be able to increase process and equipment efficiency by keeping your systems up and running all the time. We can also, as you saw in our cases, we can then decrease the production stoppages and energy consumption and decrease and remove the need of using chemicals for cleaning. All of this is also linked to our sustainability facts and something that we also are working towards to, and our clients as well. We are all in the same goal of making our production profitable, but also sustainable. And by getting rid of fouling, then you won't be using as much energy. And what this means is that also the amount of CO2 emissions will be reduced, as well as when you need to clean, and many of our clients, they need to clean with water jets as well. They are then going to use a lot more of water than intended. And we are then also able to get rid of this water issue, water consumption issue. Just to give you an idea of how we work, and happy to also discuss more with you about this point later on. Once you have a case in mind or an idea of maybe they could probably help us with this and that type of cases, we'll be happy to have a call with you and see what your thoughts are. And then after this, we have a case questionnaire that we send out, which is a guide to let you know what type of information we need. And then based on that case questionnaire, our team will be able to analyze your case and then decide what will be the best way moving forward. What is the approach that is needed? We're very transparent about it. If it is something that is out of our reach, we will let you know. We don't want to waste time with anyone. So we want to be of help for you. When it comes to our business model, the way that we want to help our clients to reach ROI as fast as possible is by providing two ways of acquiring our solution. So we're very flexible about this. Some of our clients, they like to lease the system. Some of our clients, they want to buy the system right away. So it really varies. But the way that, for example, a leasing agreement works is that once we get the details and we know how then we can help you, then we'll be able to also understand what's the time frame needed so that you can see the results. And that's then when the monthly service agreement starts. If you want to buy the system right away, then we will incorporate our services on top of that, so that it will be the planning, the hardware manufacturing, the software, which will be then working with you to have the best parameters possible to get to that high efficiency cleaning that you need, and train your staff so that they know what to expect of our system. They know how to even install it, which is very simple as well. And then we can then help you also, even if something comes up, they know what to do. Then we have the remote monitoring daily, which is very important as well, so that we know that everything is going according to plan all the time. All in all, we are really looking forward to hear from you, to know what kind of cases you have in mind. Also, what questions come to your mind after our presentation. Please feel free to contact us. We are in every social media, Twitter, Instagram, LinkedIn, Facebook. Go ahead and visit our website. We have several case studies there and further information that will be useful for you. And email us at any time. You have also Beta and my email in the first page, so feel free to reach out to us. Thank you. I think that we can start with the Q&A if that's okay for you, Said.
Yes, if anyone has any questions, please feel free to enter into the Q&A feature at the bottom. In the meantime, I think one of the questions, Esteban, we have, how long typically does the installation take?
Well, that's a very good question. It's something that we always get asked, and it varies depending on installation and the amount of transducers needed for the case. But on average, I would say from experience, I've been installing our system, it can go from 15, 20 minutes up to a couple of hours. So yeah, it's pretty much that, but it's very simple. You just need to take the clamp-on device, you put it around the desired equipment, put the transducers on it, and it's nuts and bolts, nothing else. Every time before a project starts, our technical team will schedule a training session. So we'll go through every single topic and questions that you or your team will have on site. Even now with the COVID situation, we have even been able to do everything remotely, and our clients have been doing all the work, the installation work on site. So with our guidance, they have been able to do it, and it has been working really well, and we are collaborating a lot with our customers that way.
Terry Genesis Ortiz asks if there are any Altum locations in North America.
Yes, so our office is in Las Vegas, but we have clients in California, Texas, Louisiana. And we're expanding and having conversations also with Canadian companies. We just recently and the case in Toronto. So yeah, we are in North America, and we're ready to support you at any time.
Question, can this be moved between different equipment?
Yes, also very good question. Actually, one of the best examples of this would be with valves. Sometimes it doesn't really make that much sense to have a system falling from a valve, but we have then seen how our clients are using our system by moving from section to section, not just in valves, but in pipes as well, in different segments or problematic segments. So since the system is really easy to attach and remove, then that's a good possibility. So you can just move from place to place when you need it.
And then is there any PPE, personal protective equipment, required when using Altum system?
Yes, you need to use earplugs just to be safe when our system is sonicating. I think, Esteban, do you have something to add? Earplugs, I think.
When it comes to safety, we always recommend to use earplugs or mufflers, probably around between 6 to 10 feet. If you're around the transducers, if they are sonicating, but just as a safety measure, it's not the decibels are not crazy high. They are within the industry standard, but it is recommended to use ear protection. And then when installing the system, gloves and glasses, just safety, basic safety equipment, nothing else is special. Usually it's the basic, but what you would need also in that type of industrial environment.
Great, thank you. And another question, what is the system's electrical consumption?
In Europe, the annual electricity consumption for 4-channel system is around 700 euros per year. I think it's a bit same in also in US.
Yeah, it is pretty similar. We had a case. Well, we actually continue this year with this case, which is it's seasonal, so it's for 4 months. And they had 2 channels actually, and from their information, we got to know that they were using about $100 per month on electricity. So it's very low, the consumption. And something to add here, even though our transducers per transducer we can reach up to 4 kilowatts of power, but that doesn't mean that we'll be consuming that amount. The electrical power is consumed in pulses, or the ultrasound is pulsed, so we're consuming much lower electricity because of this. So on average, per transducer will probably be between 100 or 400 watts.
Thank you. We have another question. What type of fouling is not effectively removed with ultrasound?
Good question. Actually, we haven't seen yet which ones aren't possible. We do know that, for example, polymers or also in oil and gas, they're very viscous type of fouling. Those are extremely hard to remove, but they're not impossible. It's just that we would need them to sonicate longer and with more power. So those are probably the hardest ones that we have seen.
Thank you. Does anyone have any more questions?
I don't know if Beta has related to the last question. I don't know if you have had some case in Pulp Paper where you've seen some type of scaling or fouling that were like hard or impossible to clean.
Yeah, Pulp and Paper industries or mills mainly have calcium-based or burgate the fouling, so that's not like, for us that's a good fouling type, so to say. So I wouldn't say that we don't have any fouling types that in Pulp and Paper industry or mills that we could not clean.
Question, is there potential for the ultrasonic device to damage piping?
That's also a good question. In general, no. The reason for this is, well, we have done hundreds of tests as well. And we have, even in Pulp Paper, we've been sonicating for 24/7 for how many years we have been running with Stora Enso in the same pipe?
Over 4 years now. Yeah. And we haven't seen any damages or anything. Yeah.
So, and it's actually a very good question. And part of this is related to vibrations. I think a lot of engineers, when they think about vibrations, there will be, oh, a little bit like worry about it. But in reality, it is very micro vibrations, what we use. And we are not even shaking your process. Your process is shaking our transducers, if we put it that way. So it's minimal, it's not even noticed, and it doesn't put any, or it doesn't have any issues in pipelines or a different type of equipment.
Thank you for that. Does anyone have any more questions for Esteban or Beta? All right, well, thank you, Beta, Esteban, and Altum Technologies for today's presentation. As a reminder, a survey with a link to the recording and slides will be sent to all attendees later this week. I encourage you to complete it so that we get proper feedback on how to better serve you through these presentations. Thank you all for your time. This concludes today's webinar.
Thank you, everyone.
Thank you, everybody.